Hi, good afternoon, everyone. Thank you for joining us for our presentation and introduction to BuildIT software. My name is Nolene Foster, and I head up the sales and services of laser scanners for Modena. And my co-host today is our applications engineer, Pieter Botha, who has worked on a multiple number of projects capturing 3D data for our clients who have very diverse projects. And as of late, we've been using BuildIT software to solve some complex problems that our clients are facing. So welcome to the introduction to BuildIT software and point cloud analysis. This presentation is really going to be able to give you some good insight into what the software is all about and what you could possibly achieve when using the software. So please, if you do have any questions, just pop them in the chat box and we'll try and answer them as quickly as we possibly can. Otherwise, we definitely have some time at the end of this presentation to answer any of your questions. Right, so jumping into our agenda, a quick introduction to the software, understanding client challenges, digital engineering, changing the way we work, the value of accurate data, real-life applications, some examples of how we've solved client challenges, and then Peter's going to take you through the overview of the software and its capabilities, looking at floor flatness, wall plumbness, tank analysis, 4D analysis, and then touching a little bit on construction verification, scan to BIM, beam camber, and volume computations. And as I said, we've got some time right at the end for some questions and answers. And we anticipate the webinar to be about 20. Let's have a look at the software and what BuildIT construction really is. So Faro are leveraging more than 20 years of proven software expertise. BuildIT is really an industry-leading 3D metrology software platform. So it's the first fully integrated quality assurance and quality control management tool. So it's empowering AEC professionals to continuously evaluate projects with real-time comparisons against their CAD designs by using 3D scan data, of course. And then with Faro BuildIT, you can continuously monitor the progress of construction of your building's life cycle by performing repeated quality inspections. And of course, you'll be looking at some great functions like investigating floor flatness, levelness, wall plumbness, surface deviation analysis, volumetric calculations, comparing your CAD data with point cloud data, quality control and quality checks. And of course, easily generating reports by being able to provide feedback on your quality assurance and quality control. And of course, thereby drastically reducing your rework and your errors. So essentially ensuring that design specifications are always met or adhered to. So in order to fully appreciate what's available to us now, I think we need to consider for a moment the traditional way of checking or verifying what is actually constructed versus what has been designed. And in most cases today, even when we're in possession of an up-to-date BIM authored model, the checking of the physical construction against the model is rarely as thorough or precise as it should be. And often we have clients who say, but this is the way we do it, and this is what we're used to doing, and why change? And of course, it's fair to say that although these methods, have been seen buildings going up and completed, and machines are being built and assembled through this kind of 2D documentation techniques, it's not necessarily going to take us confidently into the new digital age or give you and your company the competitive edge that we all need in doing business today. So, because really at the end of the day, we're all selling our skills or a product or a solution. And of course, forgive the analogy, it's a little like the long-winded process of posting off a letter to a loved one. Instead of really sending them just a text message with some quirky snapshots of your kids eating ice cream and their PDF report cards, new industry standards are being set, and it's going to be very interesting to see who adapts and moves forward, and of course, who won't. So digital engineering is forever changing the way we work together to design and deliver our projects. Our industry is witnessing its biggest change since CAD was introduced to our workflows. We are shifting the focus from hand sketches, 2D CAD detailing, and red pen to an all-engrossing and sometimes daunting 3D, 4D, and 5D digital world. As we know, there are increased financial and time pressures on projects lately, and forcing our teams to work smaller, smarter, and more efficiently together than ever before. But with the help of some clever software, it's certainly lifting that burden for us and for our clients. The development of an intelligent model can influence design, increase drawing accuracy, reduce human error, and of course, identify clashes before sight, while also including contingency for design changes with minimal rework. The way we design, the way we deliver and manage our projects is changing with the advancement of technology. As a company, we realized that there was a great need for quick and accurate 3D documentation for our clients. Not only did we want to help streamline their workflows, but we also wanted to offer them the possibility of the bigger picture. And of course, we're very fortunate enough to have the skill sets and the tools available to us to impact the change. And of course, with the help of the software, we've been able to help solve some complex challenges for some of our clients. For this particular client, we've done some very successful reverse engineering. We were able to validate our scan data to their CAD model to ensure that all their tolerances were met. And for a South African firm to bring this whole process in-house when it was usually being outsourced to an international company was certainly a great achievement for them and, of course, for us. And one of the architectural firms that we support were facing a legal dispute with engineers on walls that were not being built straight. And what was happening was that the ceilings were caving in. And of course, they pulled us in and asked us to support them and help with the situation. And of course, thanks to the software, we were able to quickly go in and scan and of course verify that the walls themselves were actually not the problem at all, but in fact, the liability lay with the contractors who'd installed the ceilings and of course weren't following proper protocol. So that was very interesting. And another large architectural firm, they had the challenge. They were busy with a particularly large building. It was being gutted and they were going to repurpose as a hotel, and they were under immense pressure to complete this project. And what they needed to know from us was a few things. Number one was that if their floors were level, and if so, where were the hot spots, or the low spots on the floor, how much screed they'd be able to apply to each floor without that affecting the building's structural integrity. And of course, from our viewpoint, we were able to quickly scan, pull the data into the software, and of course, extrapolate on the much needed information for them. And as an added bonus, we were also able to verify their current as-built for them. And with this client, we do continuous validating and reporting and analysis for them. This client's biggest challenge is, of course, wear and tear on their equipment. And from their viewpoint, what they really need to understand is longevity of parts and the impact this has on predictability of maintenance and repairs of their equipment. And of course, for them, having to shut down a plant for repairs costs this company substantially. So predictive maintenance is certainly going to be changing the way this company operates. So next up, Pitt's going to take you through a little bit more specifically on what you're able to do with the software and its capabilities. He's going to touch on some subjects and dive deeper into others. If you feel that you would need more information on some of the topics, please just let us know. We'd be happy to share some more data with you. Okay, thank you so much. Over to you, Peter.
Thank you, Nalin, for the introductions. Good day, everyone. My name is Peter. I will take you through BuildIT construction to show you what it can do very quickly. So first up is floor and wall analysis that we will go through. So I'm just changing the workbench for the workflow ribbons here for floor analysis. Just one thing is that we can also use the Faro S scanner to connect directly to BuildIT, and you can scan with the scanner on site connected to your laptop on site, and the data will be transferred to BuildIT, and you can immediately start processing and registering that data to be more efficient on site with on-site verification and so on. So for floor flatness analysis, the first thing we need to do is to create a surface of this point cloud. So let's create the surface by selecting the point cloud. The plane goes rather quickly. So with the plane created, we can auto-associate the points with the geometry. So with that done, the next step will be to do the surface deviation analysis. So first we need to select the surface and then start the analysis. What this will do is all the points above and below the surface will be given a value depending on the distance from the plane. So with that we get a colorful point cloud that shows us the deviation analysis on there. So you can see there's a minimum value of minus 25 and a maximum of 47 millimeters on this floor. We can also add more annotations to it on specific areas that requires more attention. So with that point I've selected, it's 1.9 millimeter deviation, and then let's select another blue point, and that point will be minus 3 millimeters. So with this analysis done, this that we see here will be added to the report later on. We can just move this out of sight of the point cloud. And then the next step will be for us to construct lines to create the floor flatness and floor levelness analysis. But first I want to hide all of this so it's not obscuring my view, and select the first point cloud again. Constructing lines is a manual process, so we will select 2 points to construct a line and press enter to set that line. I'm just going to create a few lines. So with the lines created, we need to do the floor flatness and levelness analysis, selecting the point cloud and all the lines we've added. I just want to increase this to include all the different levels of deviation there is, and we will generate that. With that analysis done, you can see the values right here, so we can move them out of sight of the point cloud. Right there, and just include all of these again to make sure that they're not overlapping. So once we're happy with that, we can generate the report from this view. Everything has been added after the floor flatness and levelness analysis to the report structure on the right hand side, including this view that we currently see. So generating the report will take a few seconds to generate. So BuildIT creates a PDF report from everything that we have done just now on the floor flatness. So you have your image right there, and then all the values of each line that has been created, and you can also see how the floor is deviating on each line. So moving on to our tank analysis, we need to select the tank analysis workflow button at the top. It will change the icons to the workflow for the tank analysis itself. So So first up, what we need to do is split the point cloud. So we have a base and then the tank itself. As you can see, there's the tank and there's the base. And then we need to do a tank volume analysis. So we give the tank a name. So let's call it tank volume. Select the point cloud. We need to select that we have scanned this tank from outside, and then we can generate the report or the volume of the tank. As you can see, BuildIT has created a mesh of the tank. So the more clean your tank is around on the outside, the more accurate your volume calculation will be. It has also added all the information on the right to the report. So let's generate the report to see what the tank volume currently is. So on the report generated, we can scroll down to the values, and we can see on the very bottom side it's 755,000 cubes for that tank. So the next step for this will be to just switch back to where we started with the point cloud on, and then we will create the geometry for the tank. So let's call this tank geometry. We select the tank's cloud, and we select the foundation cloud. And we use the inclinometer as a reference. Let's generate. With the geometry created, the next step will be to define the horizontal lines by selecting the welds. So selecting the first weld, and then select the second weld point to create all of that. So that is quite quick. And then the next step will be to define the vertical stations. I have selected 12. You can put any number in there that you want to. So creating 12, it will add that geometry to it. And then finally we can get to the deformation analysis of the tank. So we set up our parameters. I'm just going to leave them by default, but change my needle scale to 5 and generate. So all of the information generated from the analysis has been added to the deformation report on the right hand side. We can generate this report. On this report created, we have the image that was displayed on the screen. If you want a different image, we can rotate at a different angle before running the report. And we can also see the deformation on the tank on each slice that we have taken, that we have created horizontally and vertically. So the next step will be for us to create the foundation analysis. So we can set our parameters and run the analysis. And then all of this information will also be added onto the right-hand side to generate a report. So on this report, you can see the locations of the analysis that has been done and the values of them. And if this tank has been scanned using survey coordinates as well, you would have had XYZ coordinates, XYZ world coordinates added to your reporting as well. So looking at 4D cloud-to-cloud analysis, this can be done with any two point cloud projects that is of the same item, scanned at different times to compare the deviation between them. Or it can also be buildings or any other structure or item that you need to calculate deviation or deformations on as well. So we are currently using two scans within this room, scan 2 and scan 1. So we can see the deviations between those two scans. There's going to also be a verification of accuracy between two scans. These two scans were on purpose done wrong, so that we can do a cloud-to-cloud analysis with some good deviation reporting between them. So first we need to do the cloud-to-cloud deviation analysis. So we need to select a reference scan, which will be scan 2, and then a scan to be measured with, so that will be scan 1. And we can also change the color scale. I will keep it at blue, green, red and generate. This generation is quite quick. And as you can see, it has been done. I'm just going to switch off the one scan that doesn't have the analysis on it. So we have this colorful point cloud now with the color scale of the deviations on it. And from here we can do annotations. So we can select this wall there, do an annotation, and then also select that point there, do an annotation there, and then also from at this wall, just going to change the view, that point, and then that point right there. And let's also do two on the roof side. So let's do a point there and a point on the blue. Great, so with our annotations done, we can set our views to add to our report. I'm going to do a top view first, rotate the scans. So these 4 I'm going to hide to not add into my top view report. And then I will save this view as top view. Then we will go to the side view and do the same on this side. So I will hide these 2 and let's see, let's unhide this one and this one for this wall and save this view. Let's call it left side, and then we would do the same on this side. So let's hide these 2 and unhide these 2 and save this view. Right side. So with these views saved, you can see on the left hand side right here, we've got these views and we can add them to the report and generate a report from this. So once the report has been generated, we will have those images that has been saved viewed on them. So we have the top view with the deviation on those 2 spots, and then we have this left view, the left side with those 2 deviation areas, and then the right side with those 2 deviation. So everything in BuildIT is quite easy, and they've set it up so you can work with the buttons from left to right, and the workflow within it is very simple, and there's not a lot of confusion when it comes to the workflow itself. A few other things that BuildIT is capable of doing is to validate your 3D CAD drawings with your 3D scan data. You can also do wall plumbness analysis, and from there you can check your beam camber and also see if your columns and beams and walls are installed in the correct location, and also do cut and fill volume computation. We thank you for your time, and if you have any questions, we are here for you to answer. And if you want to have a 7-day trial of BuildIT construction to test out, please contact us on the details provided on the screen, and we will get back to you with a trial version.
Well, that was great. I think what Peter was trying to say there is that if you'd like access to a trial version, please just do reach out to us. My email address is up on the screen, and we'll certainly hook you up with the trial license to test out. Also just wanted to mention that if you're interested in the price, an annual subscription on BuildIT Construction is about 72,000 Rand. And if you're interested, Peter and I will be hosting 2 more webinars that are happening this month. Next up is As Built for AutoCAD on the 22nd of October. And then after that, on the 29th of October, we've got As Built for Revit. So if you're keen to see new software and what it's capable of doing, please do register. We'd love to see you. And yes, if you've got any questions, do pop them in the chat box right away. Haven't seen any questions pop up as yet. give it a few minutes in case anybody has got a question for us. Please do reach out, and then we'd be happy to answer your questions. All right. I don't think anybody's got any questions today. Okay. Well, thank you again for joining us this afternoon. We really do appreciate your time, and we hope you all have a good weekend. Okay. Goodbye, everyone.